Hello and welcome to another CS Tutor Center video. Today we're going to talk about the LeetCode problem, fruit into a basket. We're going to start by looking over the problem description, and we're going to look for keywords that will tip us off to what coding pattern to use to solve this problem. Let's get started. You are visiting a farm that has a single row of fruit trees arranged from left to right. Trees are represented by an integer array of fruits, where fruits of I is a type of fruit the ith tree produces. You want to collect as much fruit as possible. However, the owner has some strict rules that you must follow. You only have 2 baskets. Each basket can hold a single type of fruit. There is no limit on the amount of fruit each basket can hold. Starting from any tree of your choice, you must pick exactly 1 fruit from every tree, including the start tree, while moving to the right. The picked fruit must fit in one of your baskets. Once you reach a tree with fruit that cannot fit in your basket, you must stop. Given the integer array of fruits, return the maximum number of fruits you can pick. All right, so there's a lot of wordiness going on inside of this problem. We can dissect it, and let's start here. This bullet point is basically saying that you're going to make a subarray. And why is that? Well, it says starting from any tree of your choice. So remember that this fruits array holds fruit types of the ith tree. So these are like trees. Okay, so we can start from any tree we want. I'm going to start at the beginning of the tree row here. And this is, I'm going to start right here, and then it says, now you have to move to the right. Okay, and as I'm moving, I'm putting them into my basket. So what do these numbers represent? Well, these numbers represent the type of fruit. So instead of saying pear, apple, orange, orange, they use numbers. 0 fruit type, 1 fruit type, 2 fruit type, 2 fruit type. So inside of this array of trees, there are 1, 2, 3 different types of fruit. Okay, so I'm picking and I'm putting it into my basket. It says we only have 2 baskets, and each basket can only hold a single type. So that means that at most we can only have 2 types of fruits, two unique types of fruits at most. It says there's no limit to the amount of fruits each basket can hold. So we can have as many of the same fruits that we want, but we can only have 2 types of fruit at maximum. Once you reach a tree with fruit that you cannot fit in your basket, you must stop. So once we reach a tree that has well, if we have 2 types of fruit and we encounter a tree that has a 3rd type of fruit, well, we only have 2 baskets. We can't fit that in one of those 2 baskets, so we're going to have to stop. So let's see that. So I pick this, I put it in one basket. I pick this, I put it in my other basket that holds the 1 type. I pick this, but I have no basket to put into. That's a 3rd type of fruit, so I must stop. So this here was length 2. So far we have a subarray of length 2. Now I'm going to start from here, and I'll pick that, put it into one basket. I'll pick this and put it in another basket, and I'll pick this and put it in that same 2 type basket. And now I have a subarray that has 3, which is the largest subarray I can form from this array, given those constraints they give us. So 3 is the answer. Okay, let's dive down here to these constraints. So before I talk about these constraints, let me pull over this helpful list I made. So I made this list that talks about each point here is a different type of problem. These problems can all be solved with sliding window. So when we're looking at this problem, we want to ask ourselves, is it in this list? Um, well, this problem we're solving is just trying to find the maximum subarray, and it's right there in this list. So we know we can use a maximum, we know we can use the sliding window to solve this. Let's think a little bit deeper just to make sure. So what is the best big O we can have for this problem? Well, let's look at this array. So if I have this array here, I know that at minimum, I have to look at all the elements in it. So that's O of n, that's linear. Because I have to look at all the elements at least once. So the best I can do is linear. And that's because pretend I didn't. Pretend I just looked at the first one and the last one, or I just looked at the first one and the second one. Well, this isn't enough information for me to tell you what the maximum sum array is. I have to uncover these question marks before I can figure out what the maximum subarray is. So linear. Okay, so I can use sliding windows to solve linear problems. Given the way that this is written and what I'm trying to do, I can use a sliding window and I know I can do it in linear time. All right, what else? Well, you know, when we're looking at this stuff, we got to think about how are we going to keep track of the unique fruits. And this kind of tips us off here. Like if this wasn't here, if that constraint wasn't there, then we would use a hash map to where the key of the hash map is the fruit type and the value of the hash map is the number of times we saw that fruit type. We would use that. However, there's this interesting constraint here where it says that the values in the fruit array is guaranteed to be between 0 inclusive and the fruit's length exclusive. So we can do it more efficient than using a hash map now because this constraint guarantees that. Instead of using a hash map, where remember when you look up something in a hash map, it's asymptotically like constant, but it's not exactly because it has to calculate like what key to look it up in the hash map. Instead of doing that, we could use a primitive array, or just an array. You know, we can use an array and use direct access. No calculation of where we're looking up the index. So this is going to be the real world runtime is going to be faster when we use the array. You'll see that in your Leetcode. Instead of using a hash map, it'll be a little bit faster with the array. The big O is going to be the same because the big O, remember the big O is the slowest thing in the algorithm. And that hash map's not the slowest thing because it's asymptotically constant when we access something, when we read something or we insert something into it. Okay, so we'll go with the array. Thank you to them for giving us this constraint so that we could do that. All right, so let us go ahead and look at this problem here, and we'll write code. Okay, so we are looking at the problem where we have these fruit trees. So here's how we're going to do this conceptually. Let's start this out like uniques is 0, and then max length needs to be something like we'll set it to -1, something that is going to get overridden, right? Okay, so because you can't have a max length of -1. So we're going to set it to -1 because if we're done with all this and it's still -1, we know we didn't find a subarray. So we'll just return 0 length. Okay, it also helps us out when we're doing like in our code. It makes it so we can write a few less lines. We don't have to do an if check. We'll see that when we write the code. Okay, so we're going to start out with this window being the first item. So the first item here, remember, we're not dealing with like pears and apples, etc. We're dealing with numbers to represent the fruit types. So 0 is the fruit type, and we're going to go into this array. This array here we made to keep track of, we'll have it start out at 0. I made this array here to keep track of the counts of the unique fruit types, right? So down here, our index, this is the fruit types. So remember, not pear, not apple. This is fruit type 0, fruit type 1, fruit type 2, fruit type 3. Okay, and these are going to be the counts that we have of those. So for this first one, fruit type 0, so we go to fruit type 0 and increase it to 1. Okay, and since that was a 0 before I increased it, I know that we have one unique fruit now. And one unique type of fruit, right? And then I increased my window, so this came into the window. So I'm going to use this 1 to index into this, and I'm going to increment this to a 1. And since we went from a 0 to a 1, this unique type is 2 now. Okay. And my max length, my max length here, this is 2. So we have 2 so far, Before, when I had, let me back up a little bit. When it was like that, it would have been 1, right? I just didn't update it. So we're here now, so that's 2. Okay, and then I'm going to increase this. And now I increase this. 2 came into the window, so I'm going to come up here, index it, increase this from a 0 to 1. Since it went from a 0 to 1, now I have 3 unique types, which is an invalid state. We're not allowed to have 3 unique fruit types. We can only have 2 unique fruit types at most, because we only have 2 baskets, and each basket can only hold the same fruit types. Okay, so what we need to do is we need to shrink our window. We're going to shrink from behind. So that 0 fruit type just left the window, so we're going to go up to 0, and we're going to decrement it. And after we decremented it, since the count is 0 now, we know that we just totally got rid of a unique fruit type. So this is 2. Okay. And now we're going to increase this. So this 2 came into the window. So we go up to 2. So we change from a 1 to a 2. Okay, look at this. So that went from a 1 to a 2. So we're not adding a unique fruit type. We're just adding more of the same thing. And so we still have unique fruit types. We still only have 2 unique fruit types here. The fruit type 1, the fruit type 2. And these are up here are the amounts of each one of those that we have. And now we need to update the max length. So the max length here, this is 3. Okay, and then now, this will increase, but there's nothing there, so our loop ends. So we are done, and we have an answer of 3. So let's code that up. Okay, so first, the maximum fruit types. So we said that we can only have like two fruit types, 2 different fruit types at max. And then we need to keep track of the max length of our subarray. So we said we'd just say like -1 to start it out. You can't have a -1 subarray. That's going to be important because like at the end here, what we're going to do is we're going to say, does the max length equal 1? If that's the case, then we never found a subarray, so we return 0. Otherwise, we did find a subarray, and we return the max length. Okay, so now for the next part here. We're going to keep track of the uniques, the unique fruits. We'll set that at 0. And then next, we're going to keep track of the counts of the fruits that we have. This here, we got 0, 1, etc. 2, right? So this is all going to start out at 0, the counts. And then now we're going to do the sliding window. Okay, so when we're here, this is where our window starts. We started out at 0, 0. We're going to read this value, and when we read this value, we're going to put it in a variable called endFruit. And then now we're going to use that value we read to look up in our array called counts that keeps track of the fruit types, the amounts of the fruit types. And we're going to increase this. We increase this to 1, right? So let me set this to 0 first. Okay, so we increase that to 1. And we're going to check if that went from a 0 to a 1. So if it is a 1 now, that means we came from 0. If that's the case, that means we have a new unique fruit. So we increase our uniques. And then now we got to figure out, do we want to shrink this window? Like, are we in a case where we have too many unique fruits? Like, for example, this scenario. If so, we need to shrink from behind. So the window start would be at 0 in this scenario, and the window end would be at 2. So index 0 is window start, index 2 is window end. So what we need to do is we need to read from window start and use what we read to go decrement, and then we would shrink that window. So in this state, it would look like this. We got 1, 0, we got one of these, 1, 1, and we got 1, 1, 2. And then we're going to say read that and decrement, and then shrink the window. Okay, so let's see how that works. So if the uniques is greater than the max types we're allowed to have, then we'll read it. I'll put it in a variable called startFruit. And after the read happens, then the window start gets incremented, and then we use that to look up in the counts, and we decrement from the counts. And if the counts at that location now is now equal to 0, that means we just removed completely a unique fruit, all of one fruit type. So we decrement our uniques. And then now we're going to check down here if the uniques is less than or equal to the max types. Is this a valid subarray, basically? And if it's a valid subarray, then we'll just update our max length. This is where having the max length start out at 0, or sorry, -1, helps us be able to just use this math.max. If we had this like a capital integer and this was a null, then we have to do like a null check, and then we do the, blah, blah, blah. Instead of all that, we can just set this to some like value that is going to be something we'll never have, like -1, like a -1 subarray, or you can even do like integer.min value. But I'll just do -1. And then we will go ahead and do that. Okay, and I'll update our max length. All right, let's run this and see what happens. Great, we passed that, and then we'll run this. And that passed as well. Okay, great. And then I wrote the Python code. So the Python code's the same code. Again, so I just, took what I wrote here for this solution and I just wrote in the Python syntax if you want to read it in Python. So same exact code, just using Python. And then we run it, and then we submit it. Okay, great. All right, well, that's it. Thanks for watching. Please like and subscribe. That's how I get incentivized to make more videos. And I will see you guys next time. All right, thanks. Bye.